Hey guys, Mr. Ainsworth here, and I'm here to help you out, do some test corrections on Chapter 8 in Pre-Calc. So get your red pencils out or red pens and do your corrections in red and do your best. So here we go. We're going to define the amplitude, period, and phase shift here. So here the amplitude. Amplitude is right here. It's 5. Absolute value of 5 is 5. B is 6 here. So if B is 6, that means the period in general is 2 pi divided by b. So in this case, it's 2 pi divided by 6, or pi thirds. There's nothing being subtracted from x or y, so the phase shift, there's none, okay? Or you can say 0, 0. Here is 1, so the amplitude is 1. B is 2/7, so you take 2 pi divided by 2/7. And after you multiply by the reciprocal, you get 7 pi. Let me see, h is 7, k is -3. It's y minus k, so k is -3 in this case. So it's going to be 7, -3. Here the amplitude is absolute value of -3. Remember, amplitude is a distance, so you got to take the absolute value, and you get 3. Most common mistake right there is that people forget the absolute value of it and they just put down -3, so make sure you take the absolute value of it. Here h is -2 and k is 2, so -2, 2 for the shift. Right here, b is 1. Since b is 1, you got a period of 2 pi, because it's 2 pi divided by 1. Most of you guys did really well in that portion of the test right there. It's 9 points, 1 point per part. Okay, now on this one here, this is A and that's B, H, and K is -1. So the amplitude here is 3, B is pi fourths, period is 2 pi divided by pi fourths, which happens to be 2 pi times 4 divided by pi. Pi's cancel, giving you 8, period of 8. Shift is 2, -1. Remember, this is y minus k in general, so it's y minus a -1, gives you y plus 1, so k has to be negative. So h here is 2, -1, and that's the shift is always h, k in general. And the wave axis in general is y equals k. Since k is -1, we have a wave axis at -1. So what I do when I graph this beast here is that I graph the wave axis first. So graph wave axis first at -1. So let's say this is -1 here. Okay, and then I use the amplitude of 3, so I go up 3. So right here, I got amplitude of 3, down 3 here. So and then I draw these lines. Just help me guide my graph. I know it oscillates between these two lines. 3 units above the wave axis, 3 units below. Once again, the wave axis here at -1. You graph that first, then go 3 units up, 3 units down. It has to oscillate in through here. Then the question is, where does the sine function start? And typically starts at the origin, but it's been shifted 2 right, all right, 1 down. So I'm going to go 2 right, all right, 1 down. So I'm going to start here. Start there, right there at 2, 1. I go 8 units to the right, 2, 4, 6, 8. And this is where I finish for 1 period. And then as we always do, let me see this. I need to go 1/4 of the interval or the period over, and then go up to a max, back down to the wave axis, go over another 1/4 of the interval down, and then back up. So as a graph, it looks like this here. This is 1 period only. 1 period only, and that's what was asked to do. Okay, graph 1 period. Make sure you start at 2, -1 on the wave axis for the sine function. Okay, next one. What is the solution to this equation here without guessing? Okay, without guessing. Because you remember, guys, that I told you that even on multiple choice questions, you have to show your work, show your steps. And I changed this to 2 points, by the way. So what I'm going to do is I'm going to take the sine x here. And we did this one actually in one of our homework problems, or one in class, one of the two, I forget which one. But we want to transform it into one function. So you just get creative and just divide by cosine x. And look what happens. You get a familiar function right here. It's called tangent. And this right here becomes -1. And we know that tangent's negative in quadrants 2 and 4. We also know that tangent 45 degrees, or pi fourths, equals 1. We know that. But we want negative 1. So we got to go quadrants 2 and 4. So 2 and 4 here. So x could be equal to, let's see, an angle that has a reference angle of 45, or pi fourths, but in quadrant 2. Okay? And pi minus pi fourths is 3 pi fourths in quadrant 2. Alright, and 2 pi minus pi fourths will give me the quadrant 4, and that's 7 pi fourths in quadrant 4. So I've got 3 pi fourths in quadrant 2 and 7 pi fourths in quadrant 4, so it's got to be this one here. So I didn't guess, I figured it out. And you got to get from here to here, guys. You got to transform it into one function only. Alright, check your notes. We did something like this together here. In fact, it was positive. Okay, on this one here, you got to isolate your function here. So we divide both sides by 2. Alright, and we get cosine x is equal to root 3 divided by 2. Most people mastered this when they got it. But if you didn't, it's because you didn't draw your triangle right. I noticed that when I graded your test, and it's opposite of the opposite of the 30-degree angle is the small side, so you got to put the 1 here. Hypotenuse is always 2. Opposite of 30 degrees is 1. Shortest side is 1. Opposite of 60 degrees is root 3. All right. Some of you guys mix these up and got your values all wrong, and you got the problem wrong. So you got to be careful with that. We know that the cosine of 30 degrees, or pi 6 here, is root 3 over 2. Some of you guys put pi thirds here, because you got the sides mixed up and the angles mixed up. But it's actually pi 6. Now, we have answers in quadrant 1 and quadrant 4 because cosine's positive there. Some of you guys want quadrants 1 and 2, but it's actually 1 and 4. So the first one in quadrant 1 would be pi 6, and the second one would be 2 pi minus pi 6, or that's 12 6 actually. 12 6 minus 1 6 will give you 11 6, or 11 pi 6. So you're looking for two answers in 1 and 4. Okay? Okay, on this one here, you want to analyze this a little bit. Here the amplitude is 1, because there's a 1 there. B is 4, so P is equal to 2 pi divided by 4, or pi halves. The phase shift is 0, 3, so 0, 3 for shift. So you can analyze this function before you even take a look at the responses, which is a good test-taking technique. All right, and then compare. So let's keep on doing that. Here, A is 3, B is 4. So the amplitude is 3, period is 2 pi fourths, or pi halves. Shift is going to be 0, 2, so 0, 2. And on this one, amplitude is 2, B is 1, so amplitude is 3. B is 1, so the period is 2 pi now. Oops, 2 pi. Okay, and then shift is going to be 0, 2. Okay, so there are many different ways you can answer this question here. I can take a look at this one here. I can substitute 0 in my first function here. Let's see, 4 times 0 is 0. Cosine of 0 is 1, plus 3 is 0, 3. So I know this is not 1 here because this is intercepts at 0, 5. This is a 5 up here. So equation A here cannot be 1. Let's see if it's this one. This is 1, this is 2, 3, 4, 5. Can't be number 3 either. Okay, and let's see if it's 2. So let me see, 1, 2. Wait a minute, the shift. Shift 0, 3. So, oh, it's a cosine function. Excuse me. 0, 3, 1. What's been shifted? So, oh, wait a minute, what am I doing here? So 4 times 0, getting distracted, my Great Dane over here to the right, who was making some funny noises. 4 times 0 is 0. Cosine of 0 is 1. 1 plus 3 is 4. So you get 0, 4. So it can't be this one because you're at 5. Can't be this one. Can't be choice 3. Let's check this 1, 2, 3, 4, and then 1, 2, 3, 4, 5. So it can't be choice 4 here, and it can't be choice 3, and it can't be choice 1 because it doesn't have a good starting position. Okay, it's got to be choice 2. But let's see if everything else makes sense too. It's got to have an amplitude of 1. So, no. Oh, it has an amplitude of 1 right here. So A is 1. That matches. And it has to have a period of pi halves. Does that match? Let me see, from here to here. Is that pi halves? Ooh, it is. Yeah, that's pi halves. How about that? Period equals pi halves. So everything matches. So this right here has to be choice 2. Now here, if you enter in 0, 4 times 0 is 0, cosine of 0 is 1, times 3 is 3, plus 2 is 5. So 0, 5 is on this graph. So it could be 1, 3, or 4. So now we got to look at the period of pi halves. So let's do that. Man, these numbers are so small. Let me get out my glasses here. Give me a second. All right, I can't read a darn thing here. Okay, here we go. So what's the period here? What's the question here? From 0 to pi, and there's a pi right here. So here the period is pi. Here, and this is the period. Oh, it's pi halves. So here, period equals pi halves. Well, holy cow, look at that, period of pi halves. This thing starts at 0, 5, so it's probably this one here. So it matches this point's on the curve. It has the same period. Let's check the wave axis and the amplitude here. Here's the amplitude here. From 2 to 5 is 3, so amplitude of 3. Holy cow, look at that, it matches. Okay, so this is 3. All right, and now what's this one here? We got a period of 2 pi. So from here to here, from here to here is a period from negative pi to pi. Well, let me see, pi plus pi is 2 pi. Ooh, it has a period of 2 pi. So it's got to be 4. Can't be this one because it has a period of pi halves. So this one's 4. Right there. There you go. That's one way you can solve this problem, everybody. You can analyze the functions first, compare. Okay? Okay, now I notice on this one that b is 2. If b is 2, that tells me that I have 2 times 2 or 4 solutions. All right? I'm looking for 4 solutions. All right, so I'm going to change this, by the way, to 4 points. Okay, so let's do this. Let's do this thing. Let's divide by 2, and I get cosine of 2x is equal to root 3 divided by 2. I got to, again, know my triangles here. Opposite of 30-degree angle is 1, and this is root 3 here, and this is pi 6. So I get 2x is equal to pi 6 in quadrant 1. Since we did this problem, I know the other one is 11 pi 6 plus multiples of the period, 2n pi. Okay, now I have to multiply everything by a half, all right, or divide everything by 2 or multiply by half. It's the same thing. All right, and I get x is equal to pi 12, all right, 11 pi 12 plus, take a half of this, I get n pi. And by the way, that's the period. If b is 2, my period of the function is 2 pi divided by b, or 2 pi divided by 2, which is pi. This is the period. This is multiples of the period. This is how you get this is how you get more solutions, okay? All you do is take these and add pi to it and you get more solutions. So another solution is that I simply add pi. And if I add pi, I add 12 twelfths. 1 12th plus 12 twelfths gives me 13 twelfths. And I add pi to this one. So 12 twelfths plus 11 twelfths gives me 23 twelfths pi. So I have 4 solutions here. I don't have to do it again because I know I'm looking for 4. And by the way, if I add pi to that, I get 35 twelfths, and that's over 2 pi. Because again, I have to be within the domain. This is called the domain, not the range like everybody was talking about. Okay, the domain. All the set of x values is the domain. There are my 4 solutions. Okay, and remember, the way you get more solutions is simply by adding the period. That's what multiples of the period is all about. That's how you get an infinite number of solutions if you want them. All right, and now this problem here, boy, this was a fun one for you guys. And remember, anytime you see a squared function, you have an identity. And we know, I love saying that, we know that cosine squared theta is equal to 1 minus sine squared theta. It's a Pythagorean identity. So I need to make a substitution. So, because I can't have a function here or an equation with 2 functions. So I make my substitution. By the way, this is section 3. Well, I should talk about this after this. I'll tell you what sections these problems are in, and you're going to have to go back and practice. Okay, this is section, not 3. We're in chapter 8 here. 8-5. Okay, the tough section at the end of the chapter. So back to the problem here. Okay, so we make this substitution. These two things are equal. I can substitute in. Distribute now. I can distribute here and here. So I get 2 minus 2 sine squared theta equals 3 sine theta plus 3. Okay, now I'm going to add, I'm going to get my terms, I'm going to shift that over there. I'm going to subtract 2. I'm going to add a 2 sine squared theta and get everything on the right. I don't usually do this in pre-calc and show my steps like this. I just say it. When you shift things to the right, it becomes opposite in sign. Okay, these cancel, giving you 0 is equal to 2 sine squared theta plus 3 sine theta. 3 minus 2 is 1. Get that. And now you factor. Okay, if possible. So let's try to do it. So I put my factors in first. 2 sine theta times sine theta gives me 2 sine squared theta. Factors of 1 right here are 1 and 1, so you have to put those in. Everything's positive, so it has to be plus. And now you check. Sine theta, 2 sine theta gives you 3 sine theta. 1 times 1 is 1. And check with FOIL. So check with FOIL. All right. Now what you need to do is set each factor equal to 0. So you get 2 sine theta plus 1 equals 0. Sine theta plus 1 equals 0. And you solve. And what I just did there is I set each factor equal to 0. Set each factor equal to 0. Okay, that's what you did in Algebra 1. We do it here. Okay. So here you subtract 1 divided by 2 and I get sine theta equals negative 1/2. Okay, and here's the triangle again. Here we go. 30, 60, 2, 1, rad 3. You got to get good at this. And this is pi 6 again, and this up here is pi thirds. So the sine of, we know that the sine of 30 degrees gives you a half, but it's negative here. So we're in quadrants 3 and 4. So we want a quadrant 3 and a quadrant 4 answer. And my reference angle is pi 6, because sine of pi 6 gives you 1/2. So this becomes your reference angle. All right, but quadrant 3 is pi plus that. So pi plus pi 6 gives you 7 pi 6. Quadrant 4 is 2 pi minus pi 6, or 11 pi 6. So you have 7 6 pi and 11 6 pi. Ooh, we want in degrees. Let me change these to degrees. Okay, so again, this tells you degree mode. So I'll tell you what, let's change this here. So this is 30 degrees. So 30, so 180 plus 30 equals 210, right? And then 360 minus 30 equals 330. Okay, you have to have your answers in degrees, not radians. And then here, sine theta equals negative 1, and that's at the bottom of the unit circle, and we know that's 270 degrees. So we have 3 answers here. We got this one, and this one. All right, and I made that 6 points. This is a 6-pointer. All right, it's a big problem there, guys. It takes a lot of skill, and again, it's in section 8-5. So you're going to have to go back through my video and watch how we do this, step that out, because I do that quite a bit. Okay, now we're in section 8-4. All right, where we learn how to simplify and prove. So if you miss these, you got to go back and do a lot more of those. I'm just going to rewrite this in terms of sine and cosine here. So cosine A divided by sine A times 1 divided by cosine A minus cosine A. And now distribute. That's probably the easiest way you can do it. Not the only way, by the way, but the simple way. So distribute through. So we got cosine A divided by sine A times 1 over cosine A minus the second product. So cosine A, all right, divided by sine A times cosine A. All right, simplify. I get 1 divided by sine A minus cosine squared A divided by sine A. Oh, and look at that, common denominators. So combine. So I get 1 minus cosine squared A divided by sine A, and that equals, well, this right here, that's an identity. Sine squared A divided by sine A, and that just gives you sine A. That's not the only way you could do it, but that's one way. All right? All step-by-step out. All right? Step-by-step in a vertical fashion, from top down. All right? Step-by-step. And on this one here, when you prove something, you always start with the left side, which no one did on the test except I think one person. Always start, and if you watch my video of my lesson and my solutions on 8.4, I say that and I do that every single time. It's important. I'll explain why in a minute. So always start, okay, with left side, okay, the complicated side. Okay? So we start off. Here's my proof. I'm going to do it in blue. So I start off with this. I start off with exactly what I see. Okay? And I set it equal to the next step. Now, I know I see an identity right here. The easiest way to do this proof is to know your identities, and that's cosecant squared x. So I get cotangent squared x divided by, right here, cosecant squared x. But what's that? Let's dig deeper. All right, they're the same. Okay, that's an identity. You can do this thing in terms of sine and cosine, but it's a lot more complicated. So this one right here, cotangent squared x is cosine squared x divided by sine squared x, all divided by this, which is 1 divided by sine squared x. Notice how I keep my equal signs. Equals, top fraction, cosine squared x divided by sine squared x times the reciprocal, sine squared x. Notice that's 1, giving you cosine squared x, which is what we want to prove. Done. Left side, this is the left. This is the right. Once you do that, you're done with the proof. Most of you guys didn't start off with the left. You started here. I'm not trying to prove that this right here, this term is equal to cosine squared x. I'm trying to prove that this right here, cotangent squared x divided by 1 plus cotangent squared x is equal to cosine squared x. You have to start off with the left side. Okay? A lot of you guys didn't do that, so you need to do that in the future. All right, next one, calculator portion. Get it ready. Okay, B is 4. That tells me I have 8 solutions. Why? Because it's 2 times 4 is 8 times 2. That's all you have to do to determine the number of solutions here, guys. So the first thing we need to do is isolate your function. So let's go ahead and do that. All right, I got sine of 4x here is equal to 2/3. Just divide both sides by 3, okay? I'm not going to worry about the graph right at the moment. All right, now this 2/3 doesn't exist on the 30/60/90 or the 45/45/90, so it's a calc problem. So you got to take the inverse sine of 2/3. Let's do that. So 4x is equal to something in quadrant 1 and something in quadrant 2. All right, so here we go. Make sure we're going to be in radian mode here. So we want the answers in radians. Radian mode. I don't think I'm set in radian mode because I've been using it in degrees, so let's check. I'm not. Got to set it in radian mode. There we go. Oops. Select enter. Okay, quit out. Here we go. So inverse sine of 2/3. Whoops. 2 divided by 3. There you go. That's your quadrant 1 angle. Okay. And so I'm going to write that down. So 0.7 to, well, 730. 0.730. That's my quadrant 1. My quadrant 2 I'll get in a minute. Plus multiples of the period 2n pi. Now my quadrant 2 is pi minus that. So pi, minus my answer will give me my quadrant 2 angle. Sine's positive. 2/3 is positive, and sine's positive in quadrants 1 and 2. So pi minus that will give my quadrant 2, 2.412. So 2.412. And now I got to get I got to solve for x here. Well, that's simple to do. I just divide everything by 4 to get my first set of solutions here. So what do I get? I get x is equal to whatever this is, and then I get n pi halves. This is multiples of the period again. And by the way, if b is 4, my period is 2 pi divided by b. And so 2 pi divided by 4 gives me pi halves. And lo and behold, there it is. There is the period. There is the period right there. Let me just write period. That's how you get more solutions, everybody, every single time. All right, so I got to figure this stuff out. So since I already have this angle in here, I'm going to divide it by 4 immediately. Okay, that's my first solution right there, 0.603. So 0.603 plus multiples of the period, n pi halves. That means you just simply add pi halves and get more solutions. So I'm going to do that right now. I just add pi halves. All right, add it again, add pi halves, add it again, add pi halves, add it again, add it again, add it again. Okay, you just keep on doing that. So since it's already in the calculator, I'm going to keep on working on this one, and then I'll come back to the 0.370 divided by 4. Okay, so let's do this here. Let's add pi divided by 2, and I get that, okay? Plus, just keep on adding pi divided by 2, and then hit the enter button. Once you do it a couple times, you just keep hitting the enter button, boom, 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 and get as many solutions as you want. I already got the 0.603. I got these right here. If I do it again, notice that I'm beyond 2 pi, I'm beyond 6.28. So let me just write these down here. So 2.174. Okay, so 2.174. 3.745, 3.745, and this one 5.315. So 5.315. Okay, those are my 4 solutions there from this one. These are my first solutions now because I'm solving for x. Now I got to get this 0.730 back. Okay, so I need that back to start with it. So I need to take the inverse sine of 2/3 again. So I'm going to do that. So inverse sine of 2 divided by 3. I got that. Now I got to divide it by 4. Divided by 4. Notice that I'm using the answer here. Remember, the calculator is capable of holding 32 digits. It shows you about 9 or 10, but there's 22 more inside the calculator, so 32 in all. And if you only take the first 3 digits, you're chopping off, 32 minus 3, 29 digits. Not good. So use them all by recalling the answer back. So notice I took the answer and divided by 4. That's a solution right there. It's 0.18. So 0.18 right there, and then I have to add pi halves. Add again pi halves, and I just keep on doing this. Add pi halves again, and I get more solutions. You just keep adding the period, guys. That's all you do. All right, so let's do it. Add pi divided by 2 equals. That's not correct. I put e. That's incorrect. I got to start over again. Hang on for a second. Okay, clear it. Inverse sine of 2/3, okay, divided by 4. This is what happens when you don't press the right buttons, okay, plus pi, make sure you hit the right buttons, divided by 2, there we go, that's a solution, plus pi divided by 2, and then hit the enter button a couple times. So there's my first solution, 0.182. There's my next one, 1.753. 1.753. My next one is 3.324. 3.324. And next one, 4.895. 4.895. And my next one, 6.416. But this right here is beyond 2 pi, and 2 pi is 6.28. So we don't record that one. All right, so there they are. They're my 8 right here. So I got all these right here, 8 solutions. 8 solutions, guys. Okay, all you have to do is add multiples of that period, and you're good to go. Okay? I'm not going to worry about the graph right now. If you can do that, you're good to go. But I will do this. I will show you how to check this last one, which is important. So let's check the last. Always check last. Because if you can check the last one and you got that, that means the rest of them are correct. Okay, so here we go. We're going to let y1 be this, and this would be y2. So y1 equals the sine of 4x. On your calculator, y2 is equal to 2/3, and we're going to intersect them. So, alright, here we go. I'm going to clear out, go back to normal. Go back to, something that's not has functions in there. Going to enter the function in, go down the bottom one, type in 2/3, hit window, 0 to 2 pi is good, y minimum is probably good. So let's see what we got here. There we go. So there's your sine function. Since the period is pi halves, it repeats itself 4 times from 0 to 2 pi. Okay, so here, let me just grab this here. Watch this. This is cool. Give it a second here. Hang on for a second. Okay, what I want to do is I want to check the last one. Okay, so I want to go second calc, hit number 5. It asks you what the first and second curves are, so just hit enter and enter since you already entered them. Move your cursor over here. So just hit the right arrow key. Alright, and let's move over there to the right, and let's check the last solution here. That's about good enough. And look at that, lo and behold, 5.315. 5.315. Oh, that means I did it right, guys. Okay, so I'm going to pause the video. I'm going to grab this picture here. Okay, so I just showed you how we got the solution here. It's 5.315. There it is right here. When y1 here, or y2 is equal to 2/3, this is the horizontal line. Alright, and then the sine of 4x repeats itself 4 times. This is one period. Right here, that's 1. And then here's another one. 2. Here's another one. 3. And there's another one. 4. Four periods, and that's why you have why you have 8 solutions. Because take a look at it here. Once, and let me put this in blue. Once, twice, 3 times, 4 times, 5, 6, 7, 8. For every period, there's 2 solutions, and if it repeats it 4 times, 4 times 2 is 8. 8 solutions. All right, so there you go. All right, and the last thing what we need to do is pause this video first. Sorry about that. I just had a little mishap there. Okay, the last thing we need to do is solve this equation here, and all you do is let this one equal y1 and this one equal to y2. So y1 equals the sine of pi fourths x, all right, and then y2 equals a horizontal, well, not a horizontal line, it has a slope of 1/3, x thirds here, and intersect them. And the slope here is 1/3. And this right here, b is pi fourths, so we know the period is 2 pi divided by pi fourths, or 8. Right here, no shift. So let me see, we're going to start here. 2, 4, 6, 8. Put an 8 here, put a 1 here, -1 here. And then go ahead and graph your sine function here. Here, 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 and here. And then also, let's go to the left here a little bit too. So here we go. No, 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 no. No, 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 no. No, no, no. Let's go backwards here. All right, and then this function here, 1/3 x, has a rise of 1, run of 3. So we have to go up 1, run 3, right here. So let's go ahead and graph this. There we go. So we got to go, there's your slope right here. Right here, 3 up 1, right 3. There it is, 1, 2, 3, 1, 2, 3. Holy cow, that's not the, I got to redo all that. I changed the scale. That's all wrong. Let me do that again. Oh, you know what? 1/3 equals 2, 6. So up 1, right, 2, 4, 6. This is 2, and this is 4, and this is 6. Got lucky. All right, 2, 6. Nope. I got to go up to. I got to redo this. Sorry guys, I made a mistake it's a very common mistake, by the way, that I just made in front of you, because when you change the scale, you got to remember what you changed it to. So let me put the function back up there. Okay, so I have to go, let me see, this is 2, and this is 4, and this is 6. Got to go up 1, right 3, which is here. Right there, there's 1, 3. Up 1, right 3. There we go. All right, now let me graph. Now I got it right. Missed the point there a little bit, but that's close enough. All right, we have a solution here, a solution here, and a solution here. You know, what is that? x1, x2 equals 0, obviously. And then what is x3? All right, there's 3 solutions there, 1, 2, 3. The line never intersects the graph anywhere else. So now let's get it on the calculator here. Here we go. Let's go to y equals, enter it in, clear them out first. Shh. That's my son being noisy over there. And then say hi, Dustin.
Hello.
All right. So we got pi x divided by 4. And let's put in the other one, x divided by 3. All right, let's go ahead and graph. Well, we have a solution over here. We got to go change the window setting to x minimum, let's say negative pi. Watch this. Now you see it? 1, 2, 3. There it is. All right. Sorry, let me pause the video for a second. Here. Okay, before I capture this image right here, I want to calculate the intersection point. So second trace, number 5, enter, enter. Put your cursor back at your guess. Over here on the left first. We'll get the one on the right. It's symmetry, so there's symmetry involved here, so it should be the same thing but positive. So negative 2.635. Okay, so this one right here is negative 2.635. This one's 0, so x2 equals 0. That's my x1 here. So I've got solutions here. I got a negative 2.635, I got 0, and I got my third one. Let's see if it's the same value but opposite of that. I bet it is because there's symmetry involved here. So go second trace, number 5, enter, enter. Move the cursor now. Just go all the way over to the other side. There we go. Hit play. Hit enter there. Oh, lo and behold, look at that. Same thing but opposite. So 2.635. And that's this one right here. 2.635. Okay? So there you go. And whenever you want to solve an equation like this, let the left side equal y1, the right side equal y2, intersect, and go for it. And by the way, I did this in the homework solutions. If you watch my videos, I do it. And so what you guys need to do is make sure you're able to do your homework problems because these were illustrated, okay? All right, so this was, I forget what section it was, but you got to go back, practice, watch the videos, practice problems, and go into the book, check your results, do some major practice before you retest, because just by watching this doesn't mean you can solve something else until you get some major practice. All right, now practice and get good. I'll see you next time on the retake.